Okay. Let me as I sent it on the email. I want to go over on the email that I sent it to you one by one, the items that we identified, the tools that we have. One of the key things. Let me share it with you. Uh, the items one by one. See which one is which one. Okay. Here, I hope. Let me know if I sharing something that you don't see it. Let me know to make sure that we have everything is down. First, we're gonna go. Do you see the Google search for the WebAssign here, everybody?
Yeah.
Okay, good. Here, when you wanna log in, you can bookmark it later on. But this is WebAssign is a platform that all the material for the weekly activities gonna be there. When you select this one, there is two things comes here. One of them is call it with the red one, another one with the uh, blue. This is the one that we needed to work it out. This is a flexible online learning for STEM courses. The other one might be related to this one, but that sometimes might be different. Then you click on that, and then the next one you have to sign in. You click the sign in, and you provide user ID and password, and you go inside. First, I'm gonna ask all of you: do you are able to access the login, the WebAssign? Did receive a link or create an account on that or no? Rohan, Very, Arav, and Mutu. All of you,
I didn't get information on that.
you didn't have?
No.
Okay, let me go through it, and during the meeting or afterward, we give you access. Therefore, Arav, you have an account on that or no?
Yeah, I do.
And Mutu, how about you?
No, I don't have that account. I think I will not be doing it. I think Vetri will be doing it actually.
Okay, therefore, Vetri is gonna work together to make sure that get information is ready. Here, for example, this is my account, either email or account create, and your password. And when you go inside, you will see this is actually my instructor center, but you may have seen here student center. Therefore, your name might be here and the student center identify here. And the structure and format gonna be the same. The only things that you're gonna go here is my courses. And in your courses, you're gonna see three courses that we have this in fall. And they call it Looking Up Astro Marvin Rich High School, Astro 100L. This 100 Astro 100L is mainly the basics of the astronomy on the um, SkyNet University that developed by Professor Dan Reinhardt, and I am and also John Taylor, acting as a secondary instructor and teaching assistant to helping him on this course. Therefore, either of them gonna be when you click, you're gonna see another window. On this window, you're gonna have material available here, lab 1 to lab 9, as you see it in here. Therefore, this the lab 1 and 2, you see 2S and 2G. I'm gonna reach back to that on the 1 and 3 and 4. This is a completion of the OPIS 1. The reason that normally in many of the universities and schools, they taught all of them back to back. But we had experience on the last few semesters. I think it's better to divide it by somehow in 3 sections to identify those very clearly. The OPIS1 is one of the key uh, features for all of the OPISs, both OPIS 2, 3, Lab 2, 3, 4, 5, 6, and 7, and 8, and 9. It needed to know Lab 1. Therefore, on the next Thursday, we're going to go deep on this, more information about that Lab 1. And also on Tuesday as well, we're going to start with Lab 1 and Lab 7 that is related to the OPIS 3. Therefore, you don't want to miss anything if you want to start on Tuesday. We're going to have both of the Lab 1 repeated, some of them main features on both Tuesday and Thursday. And this content of this is very extensive, but I'm going to glance over quickly what you see it. For the seeing the material, you have to click view here. When you click on the view, you see it here, several sections. Lab 1, Introduction to SkyNet. SkyNet is actually this SkyNet University is a platform that Dr. Reinhardt created to uh, learn about this astronomy and astrophotography. It comes with several sections: introduction, instructions, background, procedure, um, sometimes 1 and 2. As you see it in Lab 1, we have 1 week procedure for Lab 1 and 1 week for procedure Lab 2. Therefore, uh, because of the content of the Lab 1 is extensive, we may go 2 weeks on this or finish it up on 1 week, depending how we're going to use it. And then next week, I'm going to go on different formats that you're going to use, how many digits you're going to use, and submission that you're going to have. We're going to look through it. You don't need it to know. And here, introduction is going to say what the goal of this lab is. For example, observe astronomical object with the University of North Carolina prompt telescopes. This is prompt telescopes are located in Chile and some of them in Australia and one of them in Canada. Therefore, this is the main telescope that is owned by University of the North Carolina. But there is another telescope that I'm going to show you later on that is operated by UNC Robotic Telescope Network. And then you will adjust, you're going to do some work on the pictures that you're taking and some measurement. The goal of this is the basic of the astronomy you're going to learn here, and we're going to provide some material to learn how to measure the material, angular size, brightness, and develop the images. This is the view of the dark sky in the Cerro Tololo in the prompt Chile telescopes in Andes in Chile. And it is completely dark area. And that's fantastic. You can see it, the Milky Way, easily. This is the one in the Australia. And you see in here, we have several telescopes. Therefore, it's not just one telescope, we have many telescopes. And here we're going to go about some other background information. This is a Professor Dan Reinhardt beside one of the telescopes taking the picture, some information about the filters and the colors. And then this is kind of background we're going to go over on detail and procedure. For example, how to, you want to take a picture, what the procedure you're going to use. I don't want to go too much detail here. We're going to go on next week. And here, when you finish the observation, remember, when you take a picture, sometimes the picture may not comes very good. You see here, there is some weird dots are happening here due to many different reasons. Here, you see this picture is good. This picture, again, had a problem. When that has happened, you're going to do it again. Sometimes the mount is uh, shaking or moving, and instead of the dots for a star, you see a line, and you have to do it again. And sometimes the picture that, for example, this is Jupiter. If you want to take a Jupiter and moons, you see one moon here, but other moons are out of the portion. Therefore, you have to do it again. Sometimes you see that's mount is also Earth doesn't track the Earth rotation. Sometimes the filter focus is not good. Sometimes camera is has a shutter strike, like a shutter is not opening wide, and weird things may happen. And here again, some lights nearby, some airplane goes here, and satellite or airplane, and sometimes a bug sitting on the telescope. Therefore, it just had a funny things that we cannot control that. Therefore, when it has happened, that is good as a memory that you take a picture, a bug sit over there and see, you just estimate what kind of bug you see it here. That's a natural project. But anyway, this is kind of things that we're gonna see, and then we're gonna go detail for the observing the planets, observing the moon of the planets, observing the dwarf planets like Pluto, Ceres, and many others, and observe the deeper sky objects like galaxies, nebulas, and star clusters. We're going to learn about that all celestial object, but this is basically show you how to observe and get the data from that, and also our Earth moon, and also what else we can do, and afterward for the observation. And keep in remember, the picture that we're going to take on OPIS 1, 2, 3, it's going to be black and white, something like this. You see on the social media, on your cell phone or NASA picture, you see very good picture like that. But you're not able to take a picture by neither the telescope, neither the other small telescope that you may have in your home, or you get the star party. The reason is that this one is taken by the satellite near the Mars, and you can see it very nice, and that post-processed by the very specialized camera near the Mars. But from the Earth, you cannot see more than that. But still, you can identify very good things here. For example, you see here is lighter than here. It shows exactly your polar cap of the Mars. Here is darker. It shows some dark region here. Here you see a slightly lighter. Here is lighter. Here is slightly lighter. At least by viewing this one, you can identify this is a object that has a light and the dark areas, and that is good for the astronomers to get the data out of it. Or, for example, Venus. When you take a picture of the Venus, you see the picture like this, like a crescent, like a moon. Therefore, you can easily observe this kind of objects like this. Or, for example, Jupiter, you may see it like this, and this is Saturn, and the other object, you may see it like that. Still, although you see it blurry, but it gonna get, we're gonna learn some techniques to make it better for astronomical observation. That is the scope of the lab one. Any question? I hope I didn't go very fast, but if you had any question, and also feel free if you go inside the WebAssign when you have access, you come up with question. There is a group me account that John provided. You can send it over their questions or by email. We will get back to you as soon as we can. I hearing none. Hopefully you are okay with that. Then we go to the lab 2 Earth and Season. We have two options. This is a 2S and 2G. 2S means S means we have a app using Stellarium, or you can use Google Earth to get the data. This is kind of measurements that you're gonna do for inside the Earth. The idea is that let me go over slightly to this. I sent this curriculum on the email to you earlier. This is the website of the Professor Dan Reinhardt itself, and identify what the topic is. That this is a very good diagram. It shows that what we are doing on the OPIS. We are starting from or self. Assume you are located here. we're measuring the various astronomical object, celestial object, as we go farther from ourselves. First, we measure the some dimensions on the Earth, like Earth diameter, this distance between two points, or how the season is created. That's a lab 2 concept. Then after that, we go measure the Earth um, Earth diameter by the concept we call it parallax. We're gonna go over there. You don't need it to know. We provide some material to learn better on this, and also the parallax is something to like. You can observe it like that. For example, if you look through your front wall in the place on the wall on the home on the room that you are sitting, when I close my eyes, I see, for example, my I will say a table, a drawing on my the wall in a specific location. When I change it with this one, I see it slightly moved. Therefore, this is kind of we call it parallax because when you see it with one eye, the rays that comes from the object to your eyes uh, different than this one because we have a distance between these two eyes. How much it is about 3 or 4 inches, depending on individual. Therefore, the lights that is comes around one object, it's gonna make it a triangle uh, location here. Therefore, this is we call it parallax because two eyes are on different location, and we can use this one to measure the nearby sky. You can use by this to measure very simple things in your backyard or your room or your home without measuring with the tape. Just measuring with the angle and distance that you have, you can measure the size of the object. And after that, we're going to go to the variable stars. The star that is their light is brightness changing. Sometimes it's bright, sometimes it's dim, sometimes again bright and dim. And that's help us to get know the distance of the farther distant object. That you see it here, we go farther, and then we go to the supernova, and we get the Hubble law to measure the size of the universe. Therefore, the idea of this curriculum is that we call it distance ladder. We use this technique to learn how to measure the distances in astronomy. And you're going to learn how to measure, for example, distance from Jupiter to the Earth with a error less than 5 or 6%. This is fantastic. You know, you're just sitting on behind your computer with a picture that you're taking and measuring basic knowledge of the astronomy and geometry that you learn in the school. And you can, by this basic information, you can learn how to measure distance of the galaxies and other objects with uh, very accurate data on this. And also here, it shows another triangle. Uh, it shows here the tools that we're going to have: SkyNet, prompt telescopes, radio telescopes, and Afterglow. And then OPIS is the second level. This is the introductory course, Astronomy 101 and Astronomy 102. And therefore, MWU is going to be somewhere here that we're going to reach on sometime in November on the same MW. But basic OPIS is going to cover the introductory course for astronomy. Any question? And here, another thing is important for the radio astronomy. That's a very basic thing. So when we have visually observed one thing, visually we can see it. What color you see it in rainbow? Anyone can guess on the when you see the rainbow, what the different colors you see it on the rainbow? Any idea?
It'd be like the Roy G. Biv, right? Red, orange, yellow,
Yeah,
blue,
yeah.
and violet.
It is. Yeah, it is a spectrum of the range. It started from red, orange, gradually goes to the yellow, green, uh, purple, violet, and blue. Therefore, you only see these colors. But the question comes, if you look through the spectrum. Let me bring it this one. As you see it here in the spectrum that you have it in the system, here the only part that you can see it between red and blue and purple is this much of the electromagnetic wave. Remaining here is ultraviolet, X-ray, gamma ray, gamma waves. This X-ray and gamma ray, we use it on medical. You may have know that on the medical devices you can use it. For example, I had an accident a few years ago, and they take a picture and see what happened after the uh, accident and how they're gonna fix it. That kind of things is on the medical is very purpose. But and also on the other hand, infrared and microwaves you're using to warm up your food for the lunch or dinner or breakfast, and radio wave that you hear the wave of the on the cell phone or different towers that you see it. Therefore, the only things that we can see it by color is here. The question is that what we're gonna do if we are going to look through the other part of the spectrum. This is one of the key things that we're gonna learn on the probably on the OPIS 3 and MW to assign. This is a when we take a picture, this is a visual picture that we see by different colors. But when we see it here, this is a kind of radio what do you call it, this Green Bank Observatory. It's an X-band image that shows that how much radio optical waves that gonna be different by the assigning a color. For example, when the intensity of the wave is much, we assign it red. We assign some coding to make sure that identify for this spectrum, if we're gonna look through X-ray or ultraviolet or radio waves or infrared and also microwave, we need to assign some color coding, because only we can see it the colors like this. It doesn't mean that this if we have a radio or X-ray image like this, it doesn't mean this is we can see it red. You cannot see it any red here. But this one is a code that we assign it to identify intensity of the different wavelengths on the observation of the or things. Uh, this is kind of basic that we're gonna learn on this class, and this is a curriculum that is provided on here, and I send it to you for the case. Any question for this curriculum? Thank you. And this is one of the key items that on the, let me go here on the course, we said we're going to use the Lab 2S. We're going to use Stellarium. If you type Stellarium on the Google stellarium.org, that I send a link on the email, you're going to see different option to download. You see, if you have, I don't think many people has Linux or Mac. I think Mac and Windows is more common. You can download based on the Mac if you have, or Windows 7 Plus or 10 Plus, or you can use it the web. It means that when you check this one, you don't download it. Let me check it here. You see the Stellarium comes on the internet. Therefore, you don't need it to download anything. But the other thing is that when you click on any of them, you have to download it in your computer. Download is, you can use either of them, but download has more features and free of the charge, and you can get more data on the download version than the web version. And therefore, I recommend to do based on your system download version versus the web version. But if some places that you have, for example, you don't you needed to use it on the web or your cell phone, you can use the web as well. There is no issue. Any question on Stellarium? We're gonna learn next week some features, how to tricks. There is a tricks how to use it and get the data on Stellarium. But right now we're just telling to you to learn the tools at a high level. Then next week we're gonna go on more detail. Any question?
Oh yeah. So what level of math do you need to know for this course?
What level of what? Sorry.
Level of math.
Oh, math is not needed. I'm gonna show you here. That's a good question. And let me go here. For example, let me go this one, Stellarium here. Everything, you don't need it to memorize any formula. You don't need it to do any math. All the math is done on the WebAssign. Therefore, you may need it very basic math like multiplication and division, subtraction, like that, manipulation only. You don't need it, you don't need it integration or calculus or many other sophisticated math. Let me show you one of the key things that they had. It might be here. It's helpful to get to know. I'll show you here. For example, here you go to the Stellarium, you get the data from Stellarium, and you put here whatever you provided, and um, then you calculate the error. Calculate the error. This is the sample example. This is the uh, amount of the value that you get, and this is the percentage error. The formula, everything is given. You don't need it to memorize. And there is an example here how to do that. And therefore, if you had a question, you can ask. This is a kind of very sophisticated math that we're going to have. And if there is another, therefore, it given the formula for, do you see this picture, that example? Yeah. This formula, everything is given. Therefore, this is one of the examples that is provided, and therefore you don't need it to do anything. Like another one, let me go another example here. You get some data from a Stellarium, and you put it on the empty boxes, and then that's it. And then you draw the graph, and I'm going to show you how to do that. Everything is developed here. You don't need it to memorize anything. And uh, formula and everything is here. And in addition of that, for each course, for example, if you go to the introduction, there is a embedded videos that Professor Dan provided, save it for you. You can use it to know that. Let me go to the one of the first videos to as a kind of learning procedure to get to know. This is lab 1, introduction. There is a two option. You can go original, enhanced. The difference between original and enhanced is that original has just a pure video recording of the Professor Dan for that event. But enhanced, they added some features, like they added some arrows or highlighted some items. Therefore, I think it's better to have enhanced to look through it. Let me make sure that I share it again to have a video on the system. I don't see it the chat. If I hope I didn't get any questions. Okay, then I share it the screen again. Oh, sorry. I have to make sure the video is on. Audio, sound. Yeah. Okay. Right now you see this video, enhanced video. Is that right?
No, I don't think we see it.
You don't see it?
Yeah.
Okay, let me do it again. Okay. It may
It's
take few minutes.
okay. We're seeing something.
You see
Okay.
this original and enhanced?
Yes.
Okay, good. Let me click this one. When you click this one, it's video.
All right. Welcome to lab 1 of our sequence called Our Place in Space.
You see the video?
Yeah.
You hear the video also?
Yeah.
Okay, good. This is about 2 minutes video about the introduction. We're gonna go over, and this is from these videos. Most of them is very short, 2 minutes, 5 minutes, 10 minutes. For some instruction about the OPIS that is already pre-recorded by Dan, and you can use it and learn it if you had a question. If you cannot find anything on this video, you can ask either John and myself and for the content. But we're gonna uh, go over many of these things together to make sure that we have covered.
All right. Welcome to Lab 1 of our sequence called Our Place in Space, which makes use of the SkyNet Robotic Telescope Network. Most of our labs will make use of the SkyNet telescopes, though a few will be traditional in that you'll collect your data via other means. Now, Lab 1 will take place in 2 parts, which at most institutions will be spread out across 2 separate weeks. In that first week, you'll learn how to use SkyNet, which is our image acquisition system, and you'll use SkyNet to observe a great many things, mostly solar system objects, planets, moons, dwarf planets, but also a few deep sky objects such as nebulae and globular clusters and galaxies. SkyNet will then go off and collect these images for you and get them back to you. And then in the second week of Lab 1, you'll learn how to use Afterglow, which is our image analysis system, which we also designed and developed. Using Afterglow, you'll view your images, you'll learn how to adjust the brightness and contrast in them to bring out more details. You'll learn a few basic measurement skills, such as how to measure the angular size of objects in your images. And you'll learn how to identify objects in your images. So we're going to have some fun. We're going to image a bunch of stuff. And at the same time, we're going to develop a skill set, a toolkit that we can carry forth into the remaining labs in the sequence and build on in those remaining labs. Now, the remaining labs will be based on what astronomers call the cosmic distance ladder. In Lab 2, we'll start close in on Earth scales, and as we go through the labs, we'll work ourselves farther and farther out until we're studying the universe in its entirety. Now, in the upcoming videos, I'm going to overview the different parts of these labs. In the next video, I'm going to explain the instructions that you'll find at the beginning of each lab. Then I'll overview the background sections of Lab 1. And then I'll briefly overview the procedure sections of Lab 1, and only briefly because embedded in these procedure sections are other video tutorials showing you how to do the various tasks in much more detail. Okay, that's it for this video. All right.
Hey, this is a very brief, again, same thing that we discussed together on this lab, and therefore overview of the items that we have on the SkyNet. Therefore, we're gonna go over each of them separately on each week. The next item, any questions so far on the WebAssign that you have, except I think battery has issues. We're gonna look through it and see how we can resolve it, the issue. And probably if I cannot find, if you cannot able, you don't receive anything, I may set up a password for you and you can log in on the WebAssign. Then we look through it based on that, if it's okay. Let me share it again, the course. Okay, here, therefore, the idea is that this is a basic tool that we're gonna have for the platform. And if any of your classmates has the same issue, just ask them to contact me. or John that we can set up the WebAssign for you. WebAssign gonna be for first 2 weeks gonna be free, but after the 2 weeks, they need a $65 charge for the administration of this because this program is provided by SkyNet company that providing this facility and options for the submitting your homework, and that is only administration fee that is needed for the managing us these activities. The next tool that we're gonna have is SkyNet login. Hopefully you see my screen here, and you type it SkyNet login and click on SkyNet. You see this feature here, and make sure that they may have different website on internet. The one that is we dealing with skynet.unc.edu. Edu means that is educational purpose website. Is that? Do you see this screen?
Yes.
Okay, good. Here, this is basically, we have several tabs that we're going to use here. Home is the main tab, and this is my observatory. You're going to log in on here. Before you go that, you have to log in here. When you log in, you provide a login and make an account and the password, and that's going to lead you later on. Do you have one question? Either of you have access. You can right now go and log in on that, and you will see it. You assign some number for it. Did you did you receive any link to log in on the SkyNet or not yet?
I didn't receive anything yet.
Anyone who
I got
received the
it.
link?
I did.
You did. Rohan, you did it also, right? Yeah.
I haven't
Also,
received anything yet.
I think you didn't receive it, but we'll see to see. I will assign for you the same thing and let you know to that after the class. Okay, here the basic things we go back here. Therefore, login and iObservatory, you have to log in. The other information is kind of trivial. This one is important. We're gonna go over next week on here. But when you go on here, this one telescope sites shows all the telescopes that we have on the SkyNet. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Green bank is radio, and the remaining is visual observation. That there is some help in here as well that you can use it. If I go to my observation here, you're gonna see this. We're gonna learn how to start observation, take a picture. This is some of the picture that I taking before. As you see it here, this picture is not very well developed. You see some bad features on the picture is there. Some of them, but very good. For example, here, this picture. This is very nice picture that is very sharp and good. Therefore, you can have measure all of them and learn how to do that. Therefore, this is a basic tool to take the image acquisition. We have optical observing and radio observing. This is the one that we're going to use for the OPIS 3 and this one for the OPIS 1 and 2. Any question? I'm hearing none. And for the Afterglow, you can do it Afterglow like this. It says Afterglow workshop, or the link that I provided. You can save it. UNC. You're gonna see it here. It's very hard to find. I think you have to use it, the link that you already had it on the website that I provided. But another good way to do that, you don't need it to log in on Afterglow. If you log in on a SkyNet, you are here. You can go Afterglow, and you say login via SkyNet. Therefore, you're gonna reach the this website that we're gonna learn how we're gonna maneuver on this one. Just I wanna show you how to access. Therefore, the only login you're gonna have login for the WebAssign, login for SkyNet, and through the SkyNet you can go directly to the Afterglow workbench. Any question on this? Everybody fine? Hearing none? You okay with that? Any question so far? Okay. Therefore, we go over WebAssign and the SkyNet. And another one, Astromancer. Astromancer UNC. You click on that on the link that I provided. And this one is a graphic tool. Therefore, this is kind of a tool that is created to make a graph. For example, this moon data that you're going to have, description of the moon plotting tool goes here. Or if you want to have any general curve, you're going to create here based on the data. And this is kind of various Venus or a spectrum or some information. We're going to go, not all of them, but few of them that is needed on the OPIS2, on the lab 4 and 5, probably end of the OPIS1 and OPIS2. And therefore, here, Astromancer, you don't need a login. This is free tool that is available for everybody to use it. And you can use it OPIS in space, or also you can use it for MWU. You see here two tools that you have. This one is for the MWU. For example, this is radio wave source. You see on the radio wave, we have different colors. It doesn't mean that this has different color than the others, but because the radio wave doesn't have a color in intention um, in the core of the radio wave, we don't have any color, but we are assigning some color and to identify which area has more signals than the other places. Therefore, this is both of them. We can use it for OPIS and MW. Any question? Therefore, this is briefly whatever we have on the OPIS 1, 2, and 3 tools that we have. And the remaining is related to the MWU. Therefore, let me go over the MWU. MWU is not related to the WebAssign. That is totally different features. Therefore, you don't need it to what to call it, use it the MWU from WebAssign. It's not related to the WebAssign. Therefore, you can easily use it with separate curriculum. I'm going to show you here quickly. Okay. Let me share it with you. Hopefully, this is a Word format I created here for the multi. Do you see this multi MW course material?
Yeah.
Okay, good. Here is the one we have different chapters. For example, in the solar system, we're gonna look through visible and invisible light. This is the one that we're gonna assign some colors for invisible light, how to assign it and how to identify from by the visible light. We're gonna look through the moon, Jupiter, and planets, and then we go to the star clusters and we go to some astrophotography, learning astrophotography, how to use astrophotography, and the features that we're gonna have divided on different modules. And everything, we're gonna provide this module for you, and all the links are embedded within that. For example, when we're gonna take a picture of the moon, the telescope may see only this part of the moon. Therefore, we needed to take a picture, 14 picture, for example, one picture on here, one picture here, one picture here, one picture here, another one here, another one here, another one here. That's about 14 or 15 picture, and mosaic them beside each other. It means that we bring all of them together and to make sure that we just get the all face of the moon on the picture. This is the way. This is a very basic thing that we normally does. We do on the astrophotography, mosaicing. We're gonna learn how to do that, and then we're gonna learn some basic of the photography tools that we have, some filters. The picture that you're taking, they taking you may taking with different pictures. For example, with red filter, green filter, blue, and ultraviolet, and uh, um, UV, and also light pollution filter. We may have different filters on the various telescopes that we're gonna learn. And then when we come here, as you see it, the picture is taken here by the red filter. It's showing like this. It seems to be white, but actually when we convert it to red, it's gonna be like this. And similarly, when we have a green filter, look through this uh, picture, you see it differently. And the change of the filters by different blue is going to be C. And when we combining all these three colors, we're going to see the real picture. This is basics of the astrophotography, that how the colors invented by the digital photography by taking the various wavelengths of the photo and combine it together to create a real photo and the reality. That's one of the key things that we're going to learn. And the basic, the other things you're going to learn that I don't want to go too much detail on that. Another key features here, this is one example I'm going to share it with you. Everything is in here is linked. Therefore, you don't need it to go to the platform like WebAssign. You just click here and get the access to the content of the material on the document. This is module 1, and everything is here is embedded. Like for example, here we have some videos. You can click on the video, open the video, and all other features. And here another video, and there is some features, learning features are there. Therefore, this is the very basic things that you can learn here. And also,
I can't
go
see
ahead.
the screen right now.
You can see it? Okay, let me do it again. Hopefully you can see it. Right now you see it? Thank you for letting me know. Whenever
Yes.
we go on the lab, if you don't see it, let us know and just stop us. Here, as you see it, the modules are created 1, 2, 3, 4, 5, 6, 7. We try to go for all of them, but at least I think some of them is not developed. For example, this A and the C is not developed. This is uh, not like OPIS. That is, OPIS is during the last 25 years is developed from 2000, early 2000 to 2018, 17. OPIS, it takes around 15 years or 16 years to develop curriculum. But MWU is on the process of the development, and many of them is created. The one that you see at Hypernik here, then you needed to click and on here, and you go to the modules, and on each module you have different viewed videos.
We can't see the screen again.
Okay, that might be when I click it, it go this stop it. Therefore, thank you. Let me click it again. Here, yeah. I have to learn how to make sure that it's right now. You see it. When I click that one, this bring the module 1. You see the module 1?
Yeah, we can see it now.
Okay, that then on this module you go and everything is by link is available, and some formula, and also there is some spreadsheets available for you. For example, open the link here. You're gonna get some spreadsheet. You get some measurement. You don't need it to memorize that, but you need to know what's the field of view. We're gonna learn moon diameter measurement, and when you input this data, the other data are gonna be calculated automatically, and you don't need it to do any calculation yourself. Therefore, this is basic of the Afterglow this is basic of the MWU course that we have. Therefore, that's items that we learn on this course. Any question? Thank you. Thank you, John, for sending that link on the group me. I think we're gonna send this link group me as well on the email to everybody have access, and hopefully we have learned more on this topic.
Yeah, I'm so sorry. Like I've never missed these, and I'm late tonight, so sorry something came up I could avoid. And I'm gonna put a couple links in there I did drop for the group me, and also here's the online Stellarium, and I'm sure you went through that. And I'm gonna go ahead and do the download for Stellarium also. So we have that linked up here too. Good programs to use that work really well. Now I'm just going to check my notes real quick, see if there's anything else usually we share out. I will say for the Stellarium download, the web browser is really nice. It's very quick, but the download is so much more robust, and the two are nowhere like each other. So it's nice to have the one for quick and quick looks at things, but the download version is so much better for what we'll be working on as we go forward. And my little 2 cents worth is I'm really glad you folks are here, and we're going through this together, and usually I'll be here on time and we'll go through this together. And a lot of stuff you'll be doing I've wanted to do for years. I just didn't know how to do it. So when you have questions, feel free to ask. And if you figure things out, a lot of this stuff, especially the radio, is very new for me also as we go through this. So if you learn ways to do things quicker, you're younger, you're a sharp bunch, and feel free to kind of share out those ideas with us if you discover like which observatories are giving better images, which ones aren't working, how are you selecting things, and how are you getting through assignments in a good way that it'll work well. But I think a lot of you already know who I am, so I've seen you in class and around school, and I will try to save time. I probably like Thursdays especially. If you guys want to come in, you have questions related to OPIS, or you can do in the image processing or running the robotic telescopes or anything like that, just drop by G235 and I'll work with you. And it should be, I'm looking for a lot of fun. It should be a good time as we go forward. So it should be like more class. It should be something we do together for fun, that we're all learning, and hopefully this is something that stays with you the rest of your life.
Very good. Thank you, John, for the support. And also, several things I want to remind you on top of ours that they are finishing the session. One, please provide a Gmail account or personal account than the school account email, because that has I try to send it, but it doesn't accept, and sometimes, for example, it's gonna get a difficulty to SkyNet and the WebAssign account as well. Therefore, if you had a personal account, just send it to me. Then I think Vetri, I needed that one. When you send it to me, I assign for you some password, and you can log in and you can change your password accordingly. Therefore, hopefully by next week, you set up your account and you go over and play with the different pages and information to get to know the website. And that is first week for orientation. We need it. And also, just check with the other student in the class that assigned it for this course to see if they had done this one or no, because that is very important. We make sure that WebAssign and SkyNet account is set up, and you get to know it and log in and log out and bookmark them, and also other tools that we have. As long as you get used to it earlier, that become faster to get tackle different activities in the course. And as John mentioned, this is not one-way lecture. We're gonna learn from each other. I may ask you some help on the future for many of the activity, whatever you did, and you teach us as well many other things. And also, as I mentioned, OPIS takes about 10 or 15 years to develop and is still fine-tuning as well. and also MWU as well. And we may use your input to the Professor Dan also. That the Professor Dan also gonna acknowledge your contribution, and this is not Dan's work itself. This is all the teamwork that his graduate student, his student, and himself does, and many of us also. Um, I think this is a kind of teamwork of many thousand individuals that bring this astronomy to public and learning that do activity like a citizen science and astronomer with basic knowledge. Anything, John, you think I missed it, or any other question, many others,
Yeah.
Vetri, Arvav, Ruan, or Mutu, you may have, just ask a question.
Does
So
anybody
how
have-
many? Yeah, you can go.
What's the question?
Do you have to say something? Yeah.
No, go ahead.
go ahead.
Ask if there's any
All right.
questions.
How many hours of homework is it per week?
Well, I would say, you know, an hour, we meet and reserve a couple hours each week is what I would do.
For
to do
both
that.
classes, Tuesday and
And-
Thursday.
And what it's kind of like is this is something where you could spend as much time as you want. So make sure you're doing your other homework, okay? Because this gets kind of fun and it can be kind of addictive. And start early. And like I said, in the community, share with each other. If anything's taking you a lot of time, you're making it too hard. Ask for help. Ask somebody to help you out on how to get through things. Because a lot of times, if you don't remember like the settings for the filters for a certain telescope, email somebody, and we'll just we have little help links we'll kick out really quick to try to cut this time down so you can be very efficient with your time as you do this. I think after the first week, you're going to have a perspective on how much time it takes, but you will get quicker at everything we do. Everything will seem very strange and weird, and this is, oh my word, what's going on? But once you do it and once you get your data back from the telescopes, you're like, okay, I can do this. And then you learn how to play around a little bit and change the parameters. That's where it gets, I think for me, kind of fun.
So do you have an estimate right now?
I say at the beginning, if you save a couple, 2-3 hours this first time, see how you do. If you get through everything really quick, and it might take less, but I think it's going to be dependent on each of us. Each of us is going to be a little bit different on your time. So I'll tell you, why don't you tell us how this first one goes? We get in next week and keep track of how much time you're spending, because I like to know myself how much time this does take. I'm not exactly sure.
Okay. And when you said 2 to 3 hours, does that cover MW plus OPIS 1 and 2? Like
What do you
both
think?
courses? I'm planning to take both Tuesday and Thursday classes.
I think what will happen is you're going to get quicker with both. So I don't know. It's going to be hard to say. You'll get faster is what's going to happen.
Yeah. So can I only do it on the weekends, or does image processing like take time?
Anytime you want to do it, you can do it.
Okay. So when we get an image, it's like instant.
Oh, okay. So like what I would suggest is like when we do our little talk and we show you how to do something, I would immediately go and try to get everything done if you have time to do it, because it's fresh in your head. It'll go really quick. You have to book the observations, and the observatories is dependent on the weather quite often. So if it's cloudy, it might wait till the next day. Or if they have a backlog of observations they have to do, hopefully yours comes up, or if the moon's too close or things like this happen, just realize it's good to schedule. We'll try to schedule these observations very early on, so that it'll wait until a day becomes available, then they'll do the observation. So when you learn how to do the observations, I would book a bunch of them right off the bat and get that in the works so that you can kind of get some data back to you. There's some waiting games on this, and there's some things you won't be able to image just because of where they're at. Mercury's too close to the sun right now. You're not going to get it. But Saturn and Jupiter are way far from it, and you can take images like crazy. Uranus and Neptune are in a good place right now. Venus is right on the cusp. So like that's an object. When we learn how to do that, get images of Venus right off the bat. And then you get the data back. You can complete the assignment really quick. But there's a little bit of waiting to this. It doesn't, once you, like I said, the first time you log one in, it's going to take some time. But then, I mean, honestly, it took me probably 45 minutes the first time, and I can do one now in under 5 minutes. You know, if I want to do it, it goes really quick. And then I can also change the parameters within that 5 minutes. You just get faster as you do this.
So could I do the
Ye-
bulk of the work on the weekend? Or
Yeah.
okay.
Yeah, and
So
also back to your question, John explained it very well. I think each one of you have to learn on the first few weeks to see how much it takes time. Might be on the beginning, might takes a lot of time, but if you encounter any issues, you wanna either reach out to me and John, then we can inform you quicker. Therefore, instead of the wasting time and the searching things like that. And also, you see many videos inside the labs. You don't need it to go all over all of the web, all of the videos. I think the one that we're gonna give you in 1 hour Tuesday and Thursday, it's gonna be enough to start working on that. Sometime in future, that videos is generated. Not it means that you have to start from the beginning to end each of them to learn, because we are here to give you some synopsis of the main items that is needed to know. And those videos, just in case if you need it sometime, you have a spare time on the weekend, you wanna learn a little bit more or memorize or review again, you can use it. It doesn't mean that you have to review every single item video on the labs.
Yeah, exactly. I mean, honestly, a boss goes through things so thoroughly, and he's really fine-tuned what comes off of what Professor Dan's saying, Mr. Reinhardt's doing, Dr. Reinhardt's doing, that you really could, after, if that's good enough, just do it. And I encourage you, feel free to work ahead. That way, when you come to like our Tuesdays and Thursdays, you can come and ask some questions and even speed things up a little bit more and help us out.
and one last question: is there any like further curriculum after finishing this Opus 1 through 3?
Oh, yeah, become an astronomy major in college. Go
Or
ask
like
the
next year, or like in high school?
Oh, this is beyond high school. Just let you know, okay, what you're doing. Like I said, undergraduates would love to have programs like this in all the colleges. And most colleges, it isn't. You don't do this stuff. You don't get to do it till you're maybe a junior or senior, and it's an astrophysics major, and you know a professor, and you're connected, and they show you how to do this stuff. Yeah, your high schoolers doing stuff which everybody else wants to do. So I'm glad you're in this program. It's a very special place to be.
So would I just retake it next year in sophomore year, or not take it?
Good. Yeah, and I'd say this would lead in some really cool research projects in the future. I mean, even next spring for some of you, I mean, you really could compete at science fair, regional and state science fair with this and do very well. The projects I've seen, the like last couple of years at state level, they're basically doing what you folks are learning. So, I mean, it's the tools. You're learning the stuff that makes really good research projects.
So there's no further curriculum I can take?
Well, we'll see what Dr. Reinhardt comes up with. It's hard to say. He's always pushing something new, and not right now. I don't think there is anything else yet. Yeah, we'll see how this goes.
Okay,
That was
and
a very good questions. And also, in back to the item that John mentioned, John and I, we are in process of the developing some research project for double stars that hopefully result of that research going to be publication in actual astronomical journal. Whoever completed it, kind of the training to make sure that a group of the 3 or 4 students or together. We also, John, I also we are a student also. It means that we are collecting together this material. If we have, for example, 12 individual, each 4 of us, with one group, 3 group, we can publish 3 articles in famous journals. You don't need it to have graduated in astronomy. And this is many of the amateur astronomer, they do every day, every year, and they are successful.
Yeah, and that actually me think of something else too, that actually, in a sense, we could kind of write our own course. And I've done this with students in the past, where collectively, with the knowledge base you have, we could move forward and really delve further into this, like do studies on variable stars. That'd be really cool. VSO is variable star studies, and we could find asteroids and label those, look at the Vera Rubin data, stuff like that. There's a lot of things that can spin off this once we get going. this is really learning the basis of a lot of adventures we can do in the future. It'll be just limited really to your imagination.
Could I have the email that you guys sent out?
What's that?
Could I have the email that you guys sent out that I didn't get?
So everything I have is in the chat on the side. You need an email.
Or was there like an email providing all the links that other people got?
Okay, well, I tell you, ask that in the group me, and we'll try to drop stuff in there. Anything we have. And also we'll create a shared Google Drive for everybody too, to put stuff in. That'll be helpful for this course also. Bosch,
I just had a
oh,
I just had a quick question. Is this a course that gives like any college credit or?
so what you'll get is a certificate, and this is something you put on your college apps. It's a very unique opportunity. It's kind of equivalent in a lot of ways to a college course, but you're not doing a lot of the fluff, I would say. This is, it's even, I would say this is a higher level. It's not like in class, in astronomy class, we'll go through all the basics of astronomy, all that kind of stuff. But Dr. Ryerson, like I am, it's a non-traditional astronomy class I teach, that I want you folks to be doing the science. I want you to learn how astronomy works by doing it the most enjoyable way you can do it, which is to have real observations, real data, not something that I'm making up or something that's been in a book for 30 years. Which is kind of fun. It brings you up to the big leagues in a way. I can't control the gravity detector, the wave detector out west and all that kind of stuff, but we can do what we can do. So we'll control as many telescopes as we can. And so I know, like, if you're in class, I'd like to think about how we can work some of this into our curriculum this year too, for the astronomy class. I would like to see everybody have an experience doing a remote observation to control a telescope. So that's what I'm gonna be working on this year, as well as how can I develop the radio part of your class also. So everybody collectively will be learning stuff that I hope shows up in your class also. All right.
Thank you.
I know you've all been on here for over an hour, so, and I'm sorry for being late.
No worry, no worry.
I'm looking forward to next week and what we can do. And feel free to swing by if you have questions. And we missed a few people. I'll try to reach out to them and get them up to speed so everybody can be here next week. And I would say make sure you show up each week. Watch it just 1 hour, 8 to 9. And I need to I always usually set an alarm, and I'll set an alarm and be here. So that we can learn this together and get some momentum going, so you have a good semester.
And also remember, Vetri, send the email, your personal email on the email to me that I set up WebAssign and SkyNet for you.
Yeah, I already sent one. I already sent my personal email to you.
Okay, good. Thank you. That's also if you had any classmate had a similar issue with the WebAssign and SkyNet, because I believe we have 10 people registered, but I only see 1, 2, 3, 4 so far. Therefore, make sure the others, they do the same to get the speed for the next week.
Yep. And I'm adding
Thank
you
you.
folks onto the group me, so thanks for signing up for that. Keep signing up. We'll add you to the group. Awesome. Thanks, everybody.
Thank you. Very good. And thank you very much, everyone. And if you want to, John, stay a little bit after the class,
Yeah.
after we could talk each other. But hope everyone have a great night, and see you Tuesday or Thursday.
Oh, yeah, one more thing. Is there any homework this weekend or this week?
Just try to get into the Cengage program and try to get logged in, and let us know if you have any troubles doing that. That's the biggest hiccup of this whole course, is just getting yourself in and started in the Cengage program. Once that happens, everything it's redundant. Everything's the same every week. You know where to go to the lessons, and it gets pretty simple.
Okay.
Thank you, everyone.
All right. Have a good night, everybody.
Have a good night.
Bye. Thank you for hosting this.
Welcome. Thank you.
Thank you.